Good afternoon, everybody. Happy Friday afternoon, so thank you for being here. And welcome to the Oil and Gas Transition Workshop. It is a pleasure to have you all here to think and collaborate and learn together about two enabling technologies within the oil and gas transition. Today we'll be talking about enhanced geothermal as well as network geothermal systems. My name is Gentry Higgins. I use she, her pronouns, and I am a second-year student, Master of Environmental Management over at the Yale School of the Environment across the street. And another thing about me, not that you asked, but I will indulge, is that I am very excited about the heat beneath our feet and how it can serve to decarbonize and enable significant emissions reductions within the power sector and the building sector. So, what I find particularly compelling about both EGS, enhanced geothermal systems, and network geothermal is how these technologies can leverage existing knowledge, expertise, physical infrastructure, and systems that have served the oil and gas industry for decades. And so in terms of our agenda, first we will hear from Nora and Angie, and then we will break out into smaller groups where we will have the opportunity to really dive deeper into these technologies, learning from Fervo and Heat about their respective solutions. And then we will come back together with share-outs and some closing remarks. In terms of just setting some norms for this discussion, be respectful, be curious, and take and give space as we do these small breakouts, plus you. And so, without further ado, I will go ahead and introduce our facilitators, starting with Noor. Noor is Chief of Staff at Fervo Energy. You may have heard from her yesterday, where she explained her expertise as, what was it, less of a ladder and more of a jungle gym? Correct. Yes, I love that. So Noor will be sharing about her about Fervo Energy, and as Chief of Staff, she leverages her cross-sectoral experience in climate innovation, corporate partnerships, long-term planning, and risk assurance to support Fervo's strategic initiatives, growth, and operations. And then we will hear from Angie Alberto Escobar, who is the Director of Gas to Geo Transition at HEAT, leading efforts to shift the nation's residential and commercial thermal energy sector from gas-fueled to local geothermal energy networks. She designed and administered the Commonwealth of Massachusetts flagship geothermal networks feasibility study program and continues to support municipalities in assessing geothermal potential, coordinates technical partners, and co-develops engagement strategies that prioritize community leadership and long-term resilience. So without further ado, I will go ahead and turn it over to our phenomenal facilitators. So I know you have some slides. Let's see if I can do this. Oh,
I think he taught me how.
Oh, perfect.
Yeah. All right.
Perfect.
There we go. Okay. Actually, before we sort of dive in, in the third grade in social studies class, we were asked whether we thought oil was a forever resource, like a renewable resource. Like, who thinks yes, raise your hand. Who thinks no, raise your hand. Who thinks yes? And I raised my hand, and she was like, no, it's like a finite resource. And I was shocked. I was very surprised because so much of the economy, especially in the Middle East, was so dependent on oil. And so to find out that it will eventually run out was very shocking to me, and as an 8-year-old. So so very early on, I think I started to think about what does it mean when oil is going to eventually run out? And what does it mean to build an energy system that is not dependent on a scarce resource? And so I went to, I studied sociology and international development and city planning, and was very much gung-ho about a lot of the renewable resources, the new energy technologies like solar and wind were amazing, all the battery storage, everything was fantastic, and I very much viewed oil and gas companies as what you would have thought of, like I saw them as the next wave of tobacco companies. And my husband at the time was working for an engineering company that built like LNG facilities. And so I was telling him, I was like, you don't want to work there anymore. Like, how could you be working there? Like, this isn't what you should be doing, and you should be focusing on clean energy and all that sort of stuff. And then I moved to Houston, and I gained a much more nuanced understanding of the problem, the complexity of the problem. And I think we've sort of seen those dynamics play out, especially coming from like more of the East Coast, where I live in Montreal and I lived in Boston. And I think it was very much like, you're either with us or you're against us. And then I moved to the middle of the country, or as I like to call it, the forgotten coast, because we have 3 coasts, and Houston is part of this south coast of the US. And I gained a huge understanding. And so during my time at Greentown Labs, I was able to work with a lot of different companies, including Chevron and Shell and BP, and understand like how they looked at decarbonization and what that meant. And part of that was actually, we organized an investor roadshow to bring investors from the West Coast and from the East Coast to take a look at what it means to decarbonize facilities like this. And so this used to be a Shell-owned facility. It is now a CEMEX-owned facility. And it's like this ginormous piece of just like legacy oil and gas history. And we all got in this like little bus and we're touring this. And as I was looking around, I was like, my goodness, this kind of looks just like ugly and monstrous. And like, it's just not something I want to see continuing to be built in this world. But then something really interesting happened as I like took a closer look. I started to look at just the incredible engineering that it takes to build these systems. This is amazing. Look at all the pipe. Look at like the way they move and what it means. And like, there are just so many aspects to oil and gas that are ingenious. Like, this is a representation of global ingenuity, but so much of it is American ingenuity as well, right? When we think of the ways that we've been able to apply knowledge and innovation to the shale revolution and what that's meant for America's GDP and what that's meant for us to move from being an importer of natural gas to being an exporter of natural gas, there are a host of like, just like, oh my God, this is incredible moments. And so kind of tried to look at it, I think, with more of a rosy glow. But I'm not working at an oil and gas company, nor do I want to work at an oil and gas company. And so when the opportunity to work for Fervo, which kind of see it behind me, kind of looks very similar, I was like, this is the perfect segue for taking a lot of oil and gas knowledge and expertise and incredible engineering and applying it to a solution that not only is clean, but is firm and can be so helpful to the grid. And so this is a video. Let me see if this will play. Maybe? Maybe not. Well, that's okay, but effectively what you're seeing here up to the left, that's our rig, that's where we drill, and that is all connected to a power plant. And so we're seeing so many similarities across oil and gas, and I just find that fascinating. And I think that we can use a lot of that to help transition and showcase that we don't have to leave American ingenuity behind. And actually, as we're thinking about so many of the energy innovations, whether it's solar, whether it's wind, honestly, whether it's nuclear reactors, a lot of countries, mainly China, have beaten us when it comes to like producing and exporting these technologies, but not geothermal. So this is our chance to have a very strong competitive advantage on a global scale. So what we'll do is, this is a workshop, I'm not gonna talk at you for the whole time, but during my session, we'll define the problem. So what's the key bottleneck in preventing this transition? We'll build the solution. So as a group, we'll build one big idea that could really move the needle. And then we're gonna refine the pitch. So what's the idea? Why does it matter? Who would need to make it happen? So yeah, over to you, Angie.
second. Okay. There we go. Hi, everyone. I'm Angie Alberto Escobar. I work at HEAT, a thermal energy innovation center based in Boston. We're a small nonprofit with the mission to steward forward a equitable and efficient thermal energy transition. So we're going to talk a lot about thermal energy today because it is the elephant in the room that we're not talking about a lot of the time, right? We're thinking about all of these other amazing, innovative technologies for decarbonizing many sectors, and yet the heating sector is, staring us in the face. And it's really hard to quantify heating. It's an invisible kind of energy, but we cannot continue to ignore it. So I'm going to invite you to think thermal with me. The majority of the energy that is all around us, the anthropogenic energy, if you will, and the energy consumption in the US is rejected energy from our existing processes for consuming energy. So I'm going to invite you to think thermal. At HEAT, we believe that the greatest opportunity that we have is to harness that invisible thermal energy, that anthropogenic thermal energy, the waste energy that's all around us, but also the geothermal energy that's right beneath our feet. So I did want to clarify what we're talking about because, Nora just spoke about EGS, which is incredible. Geothermal is like a last name of a family, though. It has many different cousins, sisters, family members that use the term geothermal, and so I really want to just break down which type of geothermal we're talking about. So we're not talking about drilling for extremely high temperatures to produce steam and turn a turbine and produce energy. We're also not using high temperatures for direct use in a district setting. What we're doing is closer to an individual ground source heat pump or geothermal heat pump for heating and cooling rather than creating electricity or moving hot temperature around that has efficiency losses, but rather using the stable temperature of the earth, around 45 to 65 degrees, a stable ambient temperature is what we call that, to supply water to a ground source or water source heat pump at the residential level. What I'll be talking to you about today is a geothermal network. So it takes the geothermal heat pump one step further by interconnecting the buildings with heat pumps at the building level with a distribution loop that connects them to each other and to a shared energy source, the geothermal source. This is relatively shallow geothermal, right? So we can go anywhere between 400 to 1,500 feet to access this ambient temperature. It really depends on the driller availability, what kind of drills you have around, and that will determine how deep you can go, and the overall configuration of your geothermal heat exchanger or that geogrid under in the subsurface. But this does not produce electricity, just to be extremely clear. This is a heating and cooling technology, and it's actually the most efficient way to heat and cool our homes, our built environment. So here's a closer look. You have an ambient temperature loop, a single ambient temperature loop that goes down the right-of-way of the street, similar to a gas distribution main, if you will, with service lines to each of the buildings. And in the buildings, again, you have a water source heat pump or a ground source heat pump, a geothermal heat pump. It has many names. It's the same technology that just harnesses that ambient temperature water with a little bit of antifreeze depending on the engineer, right? But the ambient temperature loop, the single pipe ambient temperature loop design is actually designed to interconnect with other loops, if you will, to each other, and you can kind of build it out like a grid. So it's scalable, it's modular, and it's decentralized. Something that you will hear why it's important. Just one second. So the idea behind designing this kind of modular, decentralized design for a geothermal network, rather than doing kind of district heating as we have done in Europe, Scandinavia, and other places, is so that we can use this kind of plug-and-play technology strategically, or in areas where there might be opportunity to decarbonize that area. So the idea is to deploy geothermal networks in an area where maybe it's the distal end of the gas system, and you can slowly demonstrate and then iterate, interconnect the systems to each other until you've backed up and pruned the gas system, so that you're only really using methane in the hardest to decarbonize sectors, like glass smelting or some industrial processes. This modularity also allows you to go beyond the gas grid and deploy it in perhaps a rural downtown area, or a place where there might be an electric grid constraint, right? So we have geothermal technologies already. We have ground source heat pumps already. Why are we networking? That's a common question that we get. And so I just want to walk through this. And so we all know that methane is a massive climate lever. If we reduce our methane emissions specifically, that the US is very dependent on for our winter heating in our homes, if we are able to curb that, we can actually have a very, very big impact on what the next millennia looks like. So you all know that methane is very, very potent. And the reason that we're networking is to reduce our reliance on the methane system, or on the gas grid. Currently, people are electrifying for our planet, right? People do know that methane is a climate lever, so they want to leave the gas system. They're leaving the gas system. Actually, heat pump cells have surpassed natural gas furnace cells, and that trend just keeps going. But the reality is that people are going to air source heat pumps, right, in a house-by-house approach. And really what this means is that the folks that can afford to leave the gas system are leaving the gas system, and the folks that are either low income, can't afford to make that choice, or just cannot make that choice because they're a renter, right, are locked in to the heating system that they have. They don't have a lot of agency over that. And what that does is, when we're doing a house-by-house approach to decarbonizing our building sector, or electrifying our building sector, it leaves the most vulnerable behind. What HEAT has proposed is, if we have these network systems, we can actually deploy the technology down a neighborhood, no matter if it's a low-income neighborhood or a mixed-income neighborhood, a high-income neighborhood. You can decarbonize at a neighborhood scale. This allows for two things. It allows you to provide distributive equity, right? Equitable access to renewable energy, but it also maintains a stable rate base if we're able to keep the same amount of customers, but just transition them with a new offering, right? And so the utility death spiral, if you will, of an aging gas system will not be burdened by those that are left behind, but rather we're stewarding forward a transition that works for everyone, and that can also, at a neighborhood scale, decarbonize our built environment at the speed that we really need to, because a house-by-house electrification approach, it will be incredibly slow. It is a very hard to reach sector. This would enable the scale that we need in order to really curb our methane emissions. At the same time, this is the amount of money that we're putting into our gas system over the next 25 years. So increasing the burden on those that are left behind, right? And so if any of so this is a map of the gas distribution work that needs to be done over the next 5 years, actually. This is not even until 2025. This is just a map of the next 5 years. The figure is the account for the next 25 years. But if we're able to deploy a modular plug-and-play technology that can serve the heating needs and also add cooling, by the way, to in these locations, in strategic locations, we might be able to reinvest these funds towards clean energy rather than into stranded assets, right? Presumably stranded assets. The Massachusetts Gas Utilities actually commissioned a study to see what the energy burden would be on low-income customers in different decarbonization pathways. And the gas to geo pathway showed the best outcome for low-income customers. There's also, self-deprivation or energy deprivation that already happens because of our affordability crisis, our energy affordability crisis. And so mitigating, adding additional burden is at the forefront of our mind at HEAT. In addition to the gas system being able to provide a solution for those would-be stranded assets, our electric grid also needs a lot of help. It also needs a lot of investment. This is our electric grid in the Boston area and the metro area. And it's going to be expensive. And so mitigating the impact to our electric grid is going to be of the utmost importance. Geothermal heating and cooling is the most efficient operationally, right? The operational savings or the operational costs, if you will, of geothermal heating and cooling is very low. And so the electricity that it's actually drawing, the heat pumps aren't working very hard. They're only moving the temperature from around 55 degrees up to, 70 degrees most people are comfortable at. So they're not working very hard. And that impact to the electric grid is something that we're thinking about at the same time when we're looking at decarbonization technologies. And he actually, our executive director, Zainab Magavi, and a few of her colleagues at Boston University actually did a study to see what the electric grid impact would be of shifting from a summer peak to a winter peak. And this is called the Falcon Curve. It's called the Falcon Curve because it's really scary when the peaks are high and the falcon is coming at you, attacking you. We're never going to decarbonize with electric baseboard, right? We're never going to do that. But just as an exercise, we saw what that impact would be. And this exercise tells us that efficiency matters, right? Because that delta, that change from that shaded in green to whatever technology we choose, that is the amount of investment that we have to put into our electric grid just to support the peaks, which drive costs. Network geothermal has an incredibly high coefficient of performance, and I'll tell you why in a second. So with a single ambient temperature loop design, the loop itself is actually bidirectional, allows for bidirectional energy flow, meaning that there can be synchronous load canceling. If one building is rejecting heat into the loop and another building is calling for heat, that heat is stored within the loop itself. There's thermal storage within that ambient temperature loop. So it brings it up just a few degrees, right? And the next building over can take those few degrees away. And so we're not even calling the thermal resources when we're able to share our thermal energy in this bidirectional way. So this is a new type of energy efficiency. I just want to say that. And it's because of this ambient bidirectional design. you might have heard of thermal energy networks. At heat, we talk about geothermal energy networks because the geo part actually allows for thermal storage. You can actually pump the ground with heat ahead of a winter peak if you're suspecting, a large peak. You can actually preload your bore field or preload your loop or preload another thermal asset that can connect to this loop. And so geothermal networks really allow for this additional dispatchability of energy. And this single ambient loop design, sorry, I keep saying single ambient loop, but it's really important, is also able to connect to a number of low-grade waste heat sources. So that could be a pond that is deep enough, or another body of water. It could also be a swimming pool or a water tank that you can just dump energy into and then access as dispatchable energy for your peak events. So we're here to talk about workforce, right? So 4.1 million gas workers are supported by the natural gas industry, right? This is important. We want our transition to be people-centered, and we can't just leave them out of the conversation. This is a huge motivator of the gas to geo pathway, actually, is having conversations, going out with the gas workforce that my colleagues have done, and really understanding that they have institutional knowledge about where that gas pipe is. It might have moved 5 feet or 20 feet over, the last 15, 20 years that they've been working those mains. And they really do have a ton of expertise about how to maintain the safety of our gas system as we're stewarding it forward into a modern age of thermal utilities rather than gas utilities. And so I just wanted to lay it all out there so that we can have shared language to discuss in the workshop. In the workshop, I'll be sharing a little bit of information about how this has actually been put into action in Framingham, Massachusetts. We have a real gas to geo workforce transition in action in Framingham, and I have some materials for you all. But in summary, I just want to go over kind of the multi-solving that this technology does. And I'm just going to skip ahead 1 second before I go through that. This is really done through HEAT's approach of aligning stakeholders and iterating constantly for what they need. And this, now I'll go back here. These are the requirements of the system. This is what everybody wants. And we, have tried to solve for all of these. We need to steward a safe and secure transition away from gas. We cannot just leave the stranded assets and stranded workers behind, because that will mean a hazardous future. But stewarding it into a fossil-free economy, a combustion-free economy, with a technology that is reliable, resilient, local, right? Underground, protected from the elements, but also with this design that I talked about, modular, scalable, and adaptable to the opportunities that exist depending on the place. It might be electric grid impacts or grid constraints, or it might be a gas main that needs to be replaced. It's highly adaptable. We talked about the workforce transition. We'll talk about that a little bit more. Equitable access is an extremely important piece of this in order to not leave folks behind. Because of the low operating cost of geothermal networks, it can actually be quite affordable for the consumer. And because gas utilities don't make money on the fuel, they make money on the capital expenditures of putting pipe in the ground, same pipe, by the way, HDPE, then this makes good economic sense for them. They will still continue their business model, just with a different energy medium. And I talked about doing it at the scale and speed we need in order to curb our methane emissions. That's of supreme importance, in a way that can support the grid as more electrification technologies are deployed, maybe not for heating and cooling, for other things, And I just want to I didn't do a slide on this because we're in the Northeast, but in the Southwest, there's a chiller moratorium, right? An evaporative chiller moratorium because of the water scarcity there. And this is a closed loop system. And so once you fill it, you don't need to fill it again. And so the water use is reduced for cooling as well. So thank you very much. I'm glad that we have this shared language, and now I'm looking forward to our workshop session.